Okay, so today we're diving into something pretty mind-blowing. We're talking blockchain and quantum computing.
Yeah, these two fields that seem like they're from different universes.
Right. Like totally separate tracks.
But they're starting to intertwine in ways that could really reshape the tech landscape.
Exactly. And we've got a stack of fascinating material to dig into. We've got stuff on a real-world quantum blockchain prototype they've actually built.
A prototype.
Yeah,
Yeah.
it's not just theory anymore. And there's this whole discussion about how governments might use blockchain.
Oh, interesting, like in public services.
Yeah, potentially even for things like foreign aid distribution. And then, of course, the whole finance world is grappling with this.
Right, because blockchain has huge implications for finance.
Public versus private blockchains, that's a big one. Plus, we'll look at the wider impact of quantum computing on business software and
The implications there are massive, right? Like across all industries.
absolutely. And to top it off, we've even got a report from Europol about the darker side of this all, how criminals might try to exploit these technologies.
I mean, it makes sense. Any powerful tool can be used for good or bad.
Exactly.
Yeah.
So our mission today is to really unpack all of this.
To give you a clear picture of where things stand right now.
The potential upsides, the potential pitfalls.
And how these two game-changing technologies are starting to collide.
Okay, so let's jump right in, and there's no better place to start than with this quantum blockchain prototype. This is research coming out of D-Wave. And
D-Wave, yeah, they're one of the leading quantum computing companies.
right, and they've actually gone beyond just theory. They've built and tested a working model.
Wow, that's impressive. It's not just an idea anymore.
And here's where it gets really interesting. They're using a new consensus mechanism. They call it proof of quantum work.
Proof of quantum work. So that's different from the proof of work that we see in, like, Bitcoin.
Exactly, because traditional proof of work uses so much energy. It's like this huge computational arms race.
Yeah, it's incredibly energy intensive. A lot of people have been criticizing that.
But with this quantum prototype, they're using the unique power of quantum computers to do the mining.
Ah, I see. So instead of brute forcing calculations like classical computers do.
It taps into the weirdness of quantum mechanics to achieve consensus in a totally different way.
And the article mentioned that they got this prototype to run across 4 different quantum processors.
Yeah, 4, which I guess is pretty impressive considering where quantum computing is at right now.
Oh, definitely. It's a sign that things are moving from theory to actual implementation.
So how does this quantum approach actually solve some of the problems that have plagued traditional blockchains?
Well, one of the biggest criticisms of blockchain has always been its energy consumption.
Right, like Bitcoin uses as much electricity as some small countries.
Exactly. And that's largely due to the proof of work mechanism. But with quantum computing, you're not relying on those same brute force calculations.
So theoretically, it could be vastly more energy efficient.
Yeah, and scalability has also been a major bottleneck for blockchains.
Like how many transactions they can handle per second.
Exactly. And this quantum blockchain uses a totally different way to generate those unique identifiers, those hashes.
It uses something called probabilistic quantum mechanics.
So there's an element of randomness to it.
In a way, yeah, it leverages the inherent probabilities of the quantum world.
That's mind-boggling. How do you even make that secure?
Well, that's where things get really complex, but they've introduced these concepts of probabilistic validation and confidence-based chain work.
So instead of everyone needing to agree on a single absolute answer.
It's more about a high percentage of nodes reaching similar conclusions.
Like a consensus based on probabilities rather than absolutes.
Right, and even though it sounds counterintuitive, the researchers say these mechanisms can provide a very high level of confidence in the blockchain's integrity.
Interesting. So even with the uncertainty of quantum mechanics, they're building trust into the system?
Okay, so what kind of results did they actually see with this prototype?
Well, the article mentions they achieved up to 75% mining efficiency.
75%? That sounds like a huge improvement.
It suggests that this approach could be way more efficient than traditional methods.
And not just in terms of energy use, potentially. In terms of scalability, too.
Right, and it also gives us a real reason to push forward with developing quantum computers.
Like a tangible application that goes beyond the theoretical.
Absolutely. It shows the practical potential of quantum computing in a very real way.
Now, the article does point out some current limitations.
I mean, it's still early days for quantum computing, right?
Yeah, obviously this is just a prototype. It's not ready for prime time.
And accessing quantum computing resources is still incredibly expensive.
So it's not like we'll have quantum blockchains running everything tomorrow.
No, but this is proof of concept. It shows what might be possible down the road.
As quantum computing technology matures and costs come down.
These limitations could become less and less significant.
Okay, so let's shift gears a bit, still staying in the realm of blockchain, but moving from the purely technical to how it might be used by governments.
Ah, yeah, there was that interesting proposal about USAID using blockchain.
Right. This idea that they could use blockchain for distributing foreign aid.
Now, that could be really transformative, potentially a lot more transparent.
And this idea apparently had some support within the Trump administration.
Oh, interesting. So it's not just a fringe idea. It had some high-level backing.
Yeah, and it was also linked to Elon Musk's DOGE Government Efficiency Unit.
Wow. So some pretty influential people were thinking about this.
So the basic premise was to use blockchain to track every dollar of aid.
To make sure it actually reaches its intended recipients.
Exactly, and to reduce inefficiencies and potentially give implementing partners more flexibility.
So it's all about bringing that blockchain transparency and accountability to the world of foreign aid.
Yeah, because right now there are a lot of concerns about how aid is managed.
Like whether it's actually effective, whether it reaches the right people,
And the proposal didn't specify exactly what kind of blockchain they envisioned.
whether it be public or private, permissioned or permissionless.
But the core idea was to create a secure and traceable record of every transaction.
So you'd know exactly where the money went, who got it, how it was used.
And this seems to tie into a broader push for more strategic and focused foreign aid programs.
Right, because there's this idea that current aid structures are too expansive and disorganized,
And that we need to focus on initiatives that are tied to measurable outcomes.
especially in strategically important regions.
And the article mentioned some other proposed changes too, like renaming USAID
Oh, yeah, to the U.S. Agency for International Humanitarian Assistance.
and potentially bringing it more directly under the control of the State Department.
So more centralized control, perhaps.
It seems that way, and it's interesting how this blockchain proposal fits into that.
Yeah, like it could be a technological tool to enable this increased oversight and accountability.
Now, it's important to remember that this was just a proposal. It wasn't actually implemented.
Right, it would have needed congressional approval.
But even so, it's a sign of the times.
Governments are increasingly looking at blockchain as a potential solution for all sorts of things.
Exactly. It's not just about cryptocurrencies anymore.
It's about how blockchain can transform the way governments operate, make them more efficient, more transparent.
Okay, let's move on to another big area where blockchain is making waves, the financial sector.
Right, and one of the key decisions that financial institutions have to grapple with is
Whether to go with a public blockchain or a private blockchain.
it's a fundamental choice with huge implications for how they use the technology.
So let's break it down. Public blockchains like Bitcoin and Ethereum.
They're open, anyone can participate.
They're decentralized. No single entity controls them.
And they're transparent. All transactions are recorded on a public ledger.
This gives them a high level of resilience. It's very difficult to tamper with them.
But it also means that financial institutions have less control over them.
Right, they have to play by the rules of the network.
And trust is placed in the system itself, the code, the cryptography.
Now, private blockchains are a different beast altogether.
You need permission to join.
And they're controlled by a select group of participants.
Often a consortium of companies or institutions.
This gives those participants more control over the network.
They can set the rules, they can decide who joins.
And they can govern the system in a way that meets their specific needs.
But they sacrifice some of that openness and interoperability that you get with public blockchains.
So it's a trade-off, right? Control versus openness.
And the choice really depends on what a financial institution is trying to achieve.
Like what their specific use case is, what their risk tolerance is.
And what regulatory environment they operate in.
It's not an ideological decision, it's a strategic one.
Exactly. It's about choosing the right tool for the job.
And it seems like the lines between public and private blockchains might start to blur,
Yeah, as blockchain technology matures, we're seeing more hybrid models emerge.
where financial institutions might use a combination of public and private blockchains.
Or they might use a private blockchain that connects to a public blockchain.
And this multi-chain future could enable some really interesting applications.
Like seamless cross-border payments or more efficient corporate treasury operations.
It's all about finding the right balance between openness control and interoperability.
And financial institutions need to think strategically about their blockchain architecture.
They need to consider not just their immediate needs, but also the long-term evolution of the technology.
And how it will shape the future of finance.
Okay, so let's zoom out even further and talk about the broader impact of quantum computing on business software.
Yeah, this is where things get really exciting. The potential is just enormous.
Because quantum computing isn't just about faster processing speeds,
It's a fundamentally different way of computing.
and it could lead to breakthroughs in areas like data analytics.
Supply chain management, cybersecurity.
And it could give businesses who adopt it early a significant competitive advantage.
We're already seeing companies like IBM, Google, Microsoft pouring resources into quantum computing research,
They're trying to figure out how to apply this technology to real-world problems.
like optimizing logistics, improving financial modeling, even accelerating drug discovery.
It's a huge area of investment and innovation.
So what kind of time frame are we looking at for this quantum revolution in software?
Well, the article breaks it down into short-term, mid-term, and long-term expectations.
Okay, so short term meaning what, like the next couple of years?
Yeah, 1 to 3 years. And in that time frame, we can expect to see advancements in cybersecurity.
Especially in developing quantum-resistant encryption.
Because as quantum computers get more powerful, they could potentially break the encryption we use today.
Right, so we need to be prepared for that.
And we might also see the emergence of quantum-inspired AI algorithms.
Algorithms that are based on principles of quantum mechanics but run on classical computers.
Exactly, and those could improve things like machine learning and pattern recognition.
So that's short term. What about midterm?
Midterm is looking at 4 to 7 years out.
And by then, we might start to see more mainstream adoption of quantum computing in businesses.
Leading to things like cost savings and faster decision-making,
Like, imagine being able to analyze massive data sets in a fraction of the time it takes now.
or optimize complex supply chains with incredible precision.
The possibilities are pretty mind-blowing.
And then the long-term 8 to 15 years out is where things get really futuristic.
Like full arealized quantum computing transforming the software landscape.
Widespread use of quantum secure cryptography,
Dramatically reduced R&D costs in industries like pharmaceuticals.
and the emergence of AI-powered quantum-enhanced decision-making platforms.
It's a whole new era of software development and application.
But of course, there are challenges along the way.
Like, what are the biggest hurdles we need to overcome?
Well, for one thing, quantum hardware is still in its early stages.
It's expensive, it's difficult to build, it's not widely available.
And we also need to develop a workforce with the skills to work with this technology.
Right, there's a huge shortage of quantum computing experts.
And then there are the security risks, too, like we mentioned earlier.
The potential for quantum computers to break existing encryption.
So we need to be thinking about that now and developing solutions.
It's a lot to consider.
Definitely. And speaking of security risks, that brings us to this Europol report.
The one about criminals potentially exploiting these technologies.
Yeah, it's a bit of a sobering reminder that any powerful tool can be used for good or bad.
And the report highlights how organized crime is getting increasingly sophisticated.
They're using AI blockchain, even looking ahead to quantum computing.
They're adapting to the evolving technological landscape, just like any other industry,
And our operations are largely moving online.
using the internet as both a tool and a target,
The report goes into detail about how AI is being used for things like phishing attacks.
creating sophisticated malware, even generating child sexual abuse material.
It's a stark reminder that these technologies are not inherently good or evil.
It's how they're used that determines their impact.
And when it comes to blockchain and cryptocurrencies, the report highlights their use in illicit payments.
Money laundering, things like that,
Criminals are using them to try to hide their transactions.
and to evade law enforcement.
They're using privacy coins. They're hopping between different blockchains.
They're exploiting decentralized finance platforms.
It's a constant cat and mouse game.
And the report even mentions this chilling idea of store now, decrypt later,
Where criminals are collecting encrypted data now.
in the hopes that they'll be able to decrypt it with quantum computers in the future.
It's a long game, but it highlights the potential long-term security risks.
And the need to develop quantum-resistant cryptography as soon as possible.
And the report also talks about how these technologies could be used to bypass sanctions.
Like in the context of the war in Ukraine.
Criminals are using encrypted communications, anonymized financial transactions, blockchain technology.
To try to circumvent trade restrictions and move goods illegally.
It's a complex web of activity, and it shows how these technologies can be used to undermine international efforts.
It's a real challenge for law enforcement and intelligence agencies.
Okay, so as we wrap up this deep dive,
We've covered a lot of ground,
we've seen how quantum computing could revolutionize blockchain.
making it more scalable, more efficient.
We've explored how blockchain could bring transparency to things like foreign aid.
We've looked at the strategic decisions financial institutions face when choosing between public and private blockchains.
We've discussed the transformative potential of quantum computing for business software across all industries.
And we've acknowledged the darker side, the potential for these technologies to be exploited by criminals.
And it really highlights this duality, right?
The potential for good and the potential for harm.
These technologies are incredibly powerful. They can be used to create a better world.
But they also present new risks and challenges that we need to be prepared for.
So for you, our listener, here's something to think about as we leave you today.
As these technologies continue to advance at an incredible pace,
What completely unexpected applications might emerge?
what new challenges might we face?
And how can we as a society prepare ourselves to navigate this uncharted territory?
It's a question worth pondering.
It's a question that will shape the future.
Thanks for joining us for this deep dive.
We'll see you next time.